Hi everyone! Today we are going to learn 11.5, which is exploring solids. So our goal today is to be able to identify solids. Quick review, a polygon. Polygon just means a shape with many sides, and a circle is not a polygon. Polyhedron is a solid that is bounded by polygons called faces that enclose a single region of space. So here are many different examples of a polyhedron. Parts of a polyhedron. The first one is a face, and a face is a flat surface of the polygon. So if we look at our example here, highlighted here in red, that is the face of that polyhedron. Next is an edge. An edge is a line segment formed by the intersection of two faces. And if we look at our example here, this line is the edge. Finally, vertex. A vertex is a point where three or more edges meet. So we have an example of a vertex here. It's the corner of the polyhedron. Classifying solids. There are two types of polyhedrons, a prism and a pyramid. So a prism has different faces that connect. A pyramid forms at the top. So we have a sharp vertex here. Things that are not polyhedrons, a cylinder, a cone, and a sphere. If you remember from a couple slides ago, we talked about how a circle is not a polygon, and if you look, we have a circle, and a sphere is a 3D circle. So that's why those are not polyhedrons. To name a prism or pyramid, we're just going to use the shape of the base. So if we look at this example here, this is a pentagonal prism because both bases are pentagons. Our triangular pyramid here because the base of this pyramid is a triangle. Let's tell whether the solid is a polyhedron. If it is, we're going to name it and then find the number of faces, vertices, and edges. So looking at A here, is this a polyhedron? And the answer is yes. How many faces? Well, we're just going to count. So we have a face here, face in the back, that's 2, and then 1, 2, 3, and then 1 on the bottom, 4. So that's a total of 6 faces. How many vertices? Well, we're going to count here. Here's a vertex, a corner, 1, 2, 3, 4, and then in the back, 5, 6, 7, and 8. So 8 vertices. Edges, remember edges just connect the vertices. So we have 1 here, so that's 1, 2, 3, 4, and then don't forget about these rectangles. 5, 6, 7, 8, and the back one, 9, 10, 11, and 12. So that is 12. And I forgot to name this polyhedron. This is a rectangular prism. All right, next. Is this a polyhedron? Yes or no? It is. This time we have a pyramid, but let's see, 1, 2, 3, 4, 5, 6. So this is a hexagonal pyramid. How many faces does it have? Well, the hexagon is 1 face, then we need to count the triangles. So 2, 3, 4, 5, 6, 7. So there are 7 faces here. Vertices, so let's just count those corners. So 1, 2, 3, 4, 5, 6, and then the top one, 7. And the edges. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 edges. Finally, is this a polyhedron? The answer is no. So we actually don't even have to answer any of these questions, and it's no because we see a circle here. Euler's theorem: the number of faces f, vertices v, and edges e of a polyhedron are related by the formula f plus v is equal to e plus 2. So we are going to start using that equation in the next couple problems. Faces. Let's start there. Well, let's count. We have a face here. We have a face on the side here, up top, the other side, and the bottom. We already counted the front one, so we're going to have to count the back. So that is 6 total faces. Vertices, well, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's use Euler's theorem. We know it's F plus V is equal to E plus 2. Well, F is 6, V is 8, and E is 12. We're going to add 2 to that, and we'll see that 14 is equal to 14. Let's tell if the solid is a polyhedron. So for number 1, the answer is yes. So let's find the number of sides, the number of faces, vertices, and edges. So if we count the faces, we end up getting 5. When we count our vertices, we end up getting 5. And edges, 8. Now, let's see if Euler's theorem works, and it should. So adding up the faces and vertices, so 5 plus 5, is that equal to the edges plus 2? Well, the edges are 8, adding 2 to that, and yes, we end up getting that 10 is equal to 10. So it works. Number 2 here, is this a polyhedron? The answer is no. Now, even though we don't have a circle, we have close to half of a circle here, a semicircle. So since we have a round edge here, it is not a polyhedron. So I'm not even going to answer any of those. Finally, is this a polyhedron? The answer is yes. So how many faces do we have? We have 5. How many vertices? Well, we have 6. And the number of edges, we have 9. So let's use Euler's theorem once again. So adding up the faces and vertices, 5 plus 6, that should be equal to the number of edges plus 2, so 9 plus 2, and that works. 11 is equal to 11. A regular polyhedron is a polyhedron in which all faces are congruent, regular polygons, and the same number of faces meet at each vertex. Convex. 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. So this is a regular convex, and this is a non-regular concave. Remember we talked about with concave, it goes inward. So that part right there makes it concave. The last thing we're going to talk about is a cross-section. A cross-section is the intersection of a plane and a solid. So if we have our pyramid here, and this plane right here is going to be the cross-section, you have to kind of use your imagination. Picture this plane cutting the pyramid. When it would cut the pyramid, this part here is the cross-section. That's what we're going to look at, and you'll see that that cross-section is a triangle. For our example here, same thing. So this plane is going to cut our cylinder, and when it does so, we're left with a cross-section if you look inside of it, and this cross-section is a circle. And here are a few more examples. Describe the shape formed by the intersection of the plane and the cube. So if we look at this plane here, our cross-section is what shape? Well, we know it's a cube, which means that that cross-section would be a square. For B, this plane creates this cross-section, and that is a rectangle. And finally, the cross-section here, we have this shape, and that is a trapezoid. I'm just going to put trap. Last slide, same thing. We're going to describe the shape formed by the intersection of the plane and the solid. So if we look at our cross section here, we have a triangle. For B, our cross section is a circle. And our last shape here, I'm not going to outline it, that is a hexagon, and I'm just going to put hex.